Hello, we'll study projectile motion. Here I have shown a level ground. A ball is thrown with initial velocity v0. So what is v0 here in the diagram? It is magnitude of the initial velocity. Theta 0 is angle made by initial velocity with the horizontal. Now origin is the point where that projectile motion starts. It's very important to select origin because in this motion it is curvilinear motion. Particle moves along a parabolic path. Here both coordinates change. So when you are asked to find position of this projectile at certain instant, then you should define coordinates. So here x coordinate and y coordinates both change. So to define the position of object, there must be origin. So we select origin where projectile motion starts. Then t0 is the time at which projectile motion starts. That means at t equal to 0, when motion starts, x coordinate is 0, y coordinate is 0, initial velocity is v0 magnitude and direction rightwards upwards theta 0. Theta 0 is angle made by initial velocity with the horizontal. Now with this velocity, if this projectile is fired, then throughout the motion it is a free motion under gravity. It experiences gravitational force and that is the only force acting on the body in air. So acceleration is due to the gravity. G is magnitude of gravitational acceleration. So this is how particle starts, and at different time instants it has a new position. So some of those instants, position at some of those instants I have shown in the diagram. Because of acceleration due to gravity, particle moves towards the ground again. During the motion, direction of motion continuously change. Remember, direction of motion means direction of velocity. Now at certain instant, say t1, v1 is magnitude of velocity, x1 is x coordinate of position and y1 is y coordinate of position. Position of particle, where the particle is at t equal to 1 second. For example, if you are asked where is this projectile at t equal to 5 seconds, then you should find x coordinate and y coordinate at t equal to 5 seconds and you will able to define the position. Horizontal distance travelled by the particle. Horizontal distance travelled by the particle from the instant where motion starts to the instant when motion ends, that is horizontal range. X coordinate of the point where motion ends. So how we define horizontal range? Horizontal distance of the point where motion ends from the point where motion starts. And this range is given by this formula, v0 squared sine 2 theta 0 divided by g. Remember the formula. We'll derive this formula in some other lectures, but most important is how to use the formula. Now the time te, remember t0, the time when motion starts, and at t equal to te, that is time when motion ends, that describes time of flight. Remember, at t equal to 0, motion starts and t equal to te, motion ends. So throughout this time duration te, particle is moving in air. So this time duration is a time of flight. So the time duration in which the projectile is moving freely in air, that is time of flight, and it is given by this formula. Time of flight is 2 v0 sine theta 0 divided by g. Now very important thing, in this case a ball is thrown from top of a building at an angle theta 0 with horizontal. Remember, these formulae are derived exactly for this situation. Now in this case, origin is the point where motion starts and here say motion ends. So this is a range. Horizontal distance, how range is defined? It is horizontal distance from the point where motion starts to the point where motion ends. So with reference to origin, this is y coordinate and this is x coordinate of the point where motion ends. Here, if you want to find range, then you should find this distance. But you cannot find this distance using this formula, range, because this formula is derived for this particular situation. So in this case, how to find the range? Of course, we are going to study. But what is very important to remember at this stage, that is both these two formulae are derived in this situation. If motion starts and ends at the same level, then only you should use this formula. From top of a building, ball is thrown at an angle theta 0 in downward direction. In this situation, now if you are asked time of flight, the time of flight is the time duration during which the ball is in the air. And this duration you cannot find from this formula. So remember once again, it's very important. These two formulae are to be used if motion starts and ends at the same level. Okay. Now, during its free motion under gravity, the maximum height reached by the projectile. Better you say maximum y coordinate of path of the projectile. Maximum y coordinate of path of the projectile, that is y max. And what is y max? Y coordinate of the highest point on the path of the projectile. And that you can find out using this formula. So y max is equal to v0 squared sin squared theta 0 divided by 2g. Remember the formula very carefully. Y max is equal to v0 squared sin squared theta 0 divided by 2g. What is y max? Don't blindly say maximum height reached by the projectile. It will create confusion while solving problem. It is maximum height reached by the projectile. No. Because it's possible that projectile starts and somewhere here projectile strikes a wall or a balloon in the air. So here projectile motion ends. So projectile does not reach the highest point on the path, remember. So better you remember this formula as maximum y coordinate of the curve along which a particle moves. So we say y max is y coordinate of the highest point on the path of the projectile. Now this curve along which projectile moves, that is path of the projectile. So what is equation of path of projectile? Here it is. Right now don't worry about proofs. We'll prove it. But at this stage you simply remember this formula. This is equation of path of projectile. Y equal to tan theta 0 x minus g divided by 2 v0 squared cos squared theta 0 into x squared. It is standard equation of parabola. So path of a projectile is a parabola with vertex of the parabola at highest point. So path of the projectile is symmetrical about the highest point. Remember this. When ball is thrown downwards at an angle theta 0 with horizontal, in this situation r, that is range, time of flight and y max formula are out of question. But still particle moves along a projectile path and this formula you can use. So this is very important formula while solving problems on projectile motion. But remember now what I am telling you. When theta 0 is measured downwards with reference to x axis, then you should use negative sign with that angle while using this formula, because this formula is derived in this situation. If suppose this angle is 30 degrees, then here you should put minus 30. If you don't consider that negative sign, then this path will be the projectile which is thrown at an angle 30 degrees upward. So that will be totally different path. Here I have given you these 4 formulae, just 4 formulae. Now try to understand. and remember this procedure of analysis. First step, choose origin where projectile motion starts, and we choose that point where motion starts. Second step, write coordinates of points known or given in the path. Now in this path, for example, if this point is mentioned in the problem or you are interested in, then you should know coordinates, x coordinate, y coordinate, and if you don't know the coordinates of the point, then label those coordinates. Here, check here, this is the point where motion ends, so its coordinates. So origin is here where motion starts, and on the same level, that is horizontal line through origin, that is x axis, on the x axis only motion ends. So y coordinate is 0 and x coordinate is horizontal distance from origin. If it is r, then positive r because it is on the right side. Position means coordinates, that is vector quantity. You will have to consider a positive negative sign for coordinates. So write coordinates of points known or given in the path, that is second step. If motion starts and ends at the same level, for example here in this diagram, if motion starts and ends at the same level, then check whether range and time of flight formula can be used. So these are range and time of flight formula. So choose origin, write coordinates. If motion starts and ends at the same level, you can use a range and time of flight formula. If that is not the case, that is if motion starts at a level and ends at some other level, then check whether equation of path can be used, equation of this curve can be used. So you must remember equation of path, y equal to tan theta 0x minus g divided by 2v0 squared cos squared theta 0 into x squared. Now remember, check whether equation of path can be used. How to check it? In fraction of a second you can take this decision whether path can be used or not. Simple. If initial velocity and coordinates data given and asked is among these 4 parameters only, then equation of path is sufficient to solve problem, remember. But other than these 4 parameters, if anything is involved in the problem, for example you are asked time, at what time particle is 20 meters above the ground, you cannot use this formula because nowhere time is involved. Or if you are asked what is velocity of the particle at t equal to 3 seconds, so nowhere time is involved, nowhere velocity at any other time instant is involved in this. In this formula, in equation of path, only initial velocity is involved. You cannot find any other velocity using purely this formula. One more thing I am telling you, listen, if time is involved in a problem, don't use equation of path. And finally, if equation of path is not sufficient, then use horizontal and vertical equations of motion. So what are these horizontal and vertical equations of motion? Try to understand. When particle moves along a projectile path, there is horizontal motion because x coordinate change, there is vertical motion because y coordinates change. So in case of projectile motion, we use equations of motion in horizontal direction as if it is rectilinear motion, and we write equations of motion in vertical direction as if it is rectilinear motion. Actual motion is combination of these 2 types of motion. During the motion, particle experiences gravitational acceleration. It is directed downwards. Now, what is x component of this acceleration? That is horizontal acceleration, and y component of this acceleration is vertical acceleration. This is a vertical acceleration. Like force, acceleration is also a vector quantity, and we are resolving this acceleration along x axis and along y axis, and what you get is its x component is 0 and y component is minus g. So for example, if it is 10 Newton downward force, then what is its Fy, y component minus 10. It's the same logic, nothing new here. So what is very important here is, in projectile motion, you will be always knowing that horizontal acceleration is 0 and vertical acceleration is minus g. So this is initial velocity v0. What is its direction? Rightwards, upwards, and its angle theta 0 with horizontal. So what is x component of initial velocity? That is v0 cos theta 0. X component of initial velocity is initial horizontal velocity. Simple logic. Y component of initial velocity is initial vertical velocity. So here when you write horizontal motion, you should think about horizontal acceleration of projectile, horizontal velocity of projectile, horizontal position of projectile. Horizontal position means x coordinate. And here you are going to write vertical acceleration, vertical velocity and vertical position. Vertical position means y coordinate. Vx is v0 cos theta 0. Try to understand. The formula is same, v is equal to u plus at. V is equal to u plus at. But what is horizontal acceleration? 0, and that is why at terms will not appear here. So horizontal acceleration is 0, and therefore horizontal velocity remains constant. Vx is horizontal velocity that remains constant. So whatever is its initial horizontal velocity, that is v0 cos theta 0, that remains the same throughout the motion. And x is equal to v0 cos theta 0 t plus x0. What is x0? Initial position, and that is 0. So you need not mention it here. So we say that x is equal to v0 cos theta 0 into t. Nothing new here, try to understand. It is actually x is equal to ut plus half at squared. That is the same formula. But half at squared, acceleration 0. Horizontal acceleration is 0. That's why this half at term is not involved here. X is equal to v0 cos theta 0 t. That's all. What is v0 cos theta 0? Initial horizontal velocity. Now ay minus g, it is uniform acceleration motion. So vy is equal to v0 sin theta 0 minus gt. The same formula, v is equal to u plus at. Only for vertical components the formula we have used. This is vertical velocity, this is initial vertical velocity. And at, v is equal to u plus at. U is initial vertical velocity, in this case v0 sin theta 0. This is vertical acceleration. And y is equal to ut plus half at squared plus y0. Y0 means initial y coordinate. It is 0 because the point where motion starts, we have chosen that as origin. So we need not mention y0 here. So have you realized it is same regular uniform acceleration motion formula, x is equal to ut plus half at squared. Only thing is here it is vertical motion we are writing, so y coordinate, vertical position is changing. This is initial vertical velocity, that is vertical component of initial velocity, it is upwards v0 sin theta 0 and half at squared. And what is acceleration? It is negative and magnitude is g. So these are standard equations of motion, same formula which you are using in uniform acceleration motion. Acceleration constant, v is equal to u plus at, x is equal to ut plus half at squared. Here a we have replaced by minus g. So now let's focus on procedure of analysis. Choose origin where projectile motion starts. Write coordinates of points known or given in the path. If motion starts and ends at the same level, then check whether range time of flight formula can be used. If it is not the case where motion starts and ends at the same level, then of course you must not use these two formulae. Then check whether equation of path can be used. Equation of path can be used only when coordinates and initial velocity involved in the problem. Other than this, if anything else is asked, don't use equation of path, use equations of motion. This procedure of analysis will keep you on right track while solving problems, and very smoothly, fluently you will arrive at the final answer. So these are the 4 equations, very important. Equations of motion. Okay. Read this problem. An airplane is flying in horizontal direction with velocity 630 kilometers per hour at height 2500 meters. When it is exactly above point A on the ground, so here I have shown ground, when it is exactly above point A on the ground, a body is dropped from it. The body strikes ground at point B. Determine distance AB. You must be able to visualize the situation given in the problem. So this is the situation and you are asked to find the distance AB. Now nothing to think here, just follow the procedure. So now let's follow the procedure. Airplane is flying at a height 2500 meters from ground. That means the body is released 2500 meters above the ground. Initial velocity of the body is equal to velocity of airplane, that is 175 meters per second, and we are asked to find this distance AB. Let's follow the procedure. Choose origin where projectile motion starts. That is our first step. So I have chosen origin where projectile motion starts. Write coordinates of points known. So point B is in the path. So write coordinates. R, that is x coordinate, and minus 2500, that is y coordinate. Don't forget this negative sign. It is below origin. If motion starts and ends at the same level, then check whether range and time of flight formula can be used. So as per my procedure, we should not think about using range of and time of flight formula. Check whether equation of path can be used. How to check it? Remember, given and asked is amongst these 4 parameters. Then we use equation of path. Let's check here. V0 is given 175 meters per second. It is magnitude of initial velocity. Theta 0 is angle made by initial velocity with horizontal, and it is 0. X coordinate R and y coordinate minus 2500, and what you want to know? R. So this is that equation of path. Y is minus 2500. Tan theta 0 means tan 0 is 0 minus G is 9.8 divided by 2 V0 squared, that is 175 squared, into cos squared theta 0, but theta 0 is 0, cos 0 is 1, and that is why it's 1, into R squared, and you will get the answer. So this is the solution to the problem. So remember this procedure. If equation of path is not sufficient, then use horizontal and vertical equations of motion. So this is what is our entire procedure of solving problem, but here we got the answer using equation of path only. Read this problem. A stone thrown with speed 15 meters per second at an angle 60 degrees with a building strikes ground 13 meters from the building as shown in the figure. Determine height of the building. Okay, so from top of the building a ball is thrown. So when you are solving a projectile motion problem, you will think in this manner only. Choose origin where projectile motion starts. So I have chosen origin. Write coordinates of points given in the path. So I have written coordinates of the point. X coordinate is 13. Check from origin. Visualize that L. So vertical coordinate is minus h. Y coordinate is minus h. So write coordinates given in the path. If motion starts and ends at the same level, no, not at all. After this, check whether equation of path can be used. XY coordinate and V0 theta 0. Out of these 4 parameters, let's check what we know. V0 is known, theta 0 is minus 30, X is 13 meters and Y is minus h. And you want to know this h, height of the building. Here X is X coordinate, Y is Y coordinate, Y is not height of the building. In this situation, Y coordinate is minus h, where h is height of the building. Now most important of the problem is this. What is theta 0? It is angle made by initial velocity with horizontal. So certainly theta 0 you should not substitute 60 degrees. It is minus 30 because it is 30 degrees downwards. If you use here plus 30, positive 30, or if you forget to use negative sign, then it will become a ball thrown at an angle 30 degrees upwards, and that will be a different path you are going to use, and some other point you will get, and that is mistake. You will get wrong answer. So this is very important to remember. So it is equation of path problem, one step problem again. Just put the values and get the answer. Y coordinate minus h, tan of minus 30, theta 0 is minus 30, just put the values. X coordinate is 13, 9.8 g, 2 into 15 square, that is V0, magnitude of initial velocity, cos of minus 30 squared into 13 squared. So take a pause, do this calculation practice is important, and you will get the answer. Let's solve this problem. A projectile is fired with initial velocity 1000 meters per second at an angle 60 degrees with the horizontal. The projectile strikes the surface whose equation is y equal to 10 raised to minus 8 x squared. Equation of this curve, surface, y is equal to 10 raised to minus 8 x squared. So projectile strikes at point B as shown in the figure. Find elevation y dash, that is vertical distance from ground, that is called elevation. You want to find y coordinate of point B, you want to know y dash. So let's proceed, follow the procedure. Choose origin where projectile motion starts. So point A is nothing but origin now. Write coordinates of points known or given in the path. So let's write coordinates of point B. What is x coordinate? That is also unknown. So we'll label this way, x dash, y dash. If motion starts and ends at the same level, of course not. A and B are not at the same level. Check whether equation of path can be used. Remember what I said? If given and asked are among these 4 parameters, then we should use equation of path. Now check here, initial velocity given and you are asked to find y coordinate. So given and asked are amongst these 4, so we are going to use equation of path. So in equation of path you will put V0 1000 meters per second, magnitude of initial velocity, theta 0 60 degrees, angle made by initial velocity with horizontal, x you will put x dash and y you will put y dash. So xy coordinates of a point in the path given x dash y dash. But now here problem is, there are 2 unknowns in equation of path. Which 2 unknowns you will get in equation of path? X dash and y dash. To solve for 2 unknowns there must be 2 equations, and second equation is already given in the problem. Point B is on this surface, means coordinates of point B satisfy this equation also. So we can say that y dash equal to 10 raised to minus 8 x dash squared. Last step, no necessary at all. Using equation of path we will able to solve the problem. So let's put the values. This is equation of path, y equal to tan theta 0 x minus g divided by 2 v0 squared cos squared theta 0 into x squared. Mug up this formula. Put the values. So what is y? Y is y dash, x is x dash, theta 0 is 60 and v0 1000, g 9.8. Just put corresponding values and here you will get one equation with 2 unknowns. So this is equation 1 with 2 unknowns, and one more equation, that is equation of the surface. We can write y dash equal to 10 raised to minus 8 x dash squared. This is equation 2, and from equation 1 and 2, that is put y dash as 10 raised to minus 8 x dash squared in equation 1. So y dash will replace by 10 raised to minus 8 x dash squared. So you got one equation with only one unknown. In all these 3 terms, this term, here this term, and x dash is involved. So divide this equation by x dash. So take a pause, do these calculations and you will get x dash. This is what x dash is. And put x dash in equation 2, and also you may put it in equation 1 also, but equation 2 is smaller. So put it in equation 2 and you have found out y dash. So this is how, it's very straightforward problem. Let's solve this problem. A shot is fired with velocity 50 meters per second from a point 25 meters in front of a vertical wall 12 meters high. Find angle of projection to enable the shot just to clear the top of the wall. G is 9.81 meters per second square. So first of all, let's visualize the situation involved in the problem. When there is height involved, height of the wall is given 12 meters high. There is ground involved. Height is always measured from ground. So this is ground. Where projectile is fired, that is origin. From origin, at distance 25 meters, there is vertical wall which is 12 meters high. So this is that situation, 25 meters in front of a vertical wall. A shot is fired. So shot is fired at point O. Find angle of projection. Magnitude of initial velocity is given. Shot is fired with velocity 50 meters per second, but angle of projection is not given. But the requirement is this shot should just clear the top of the wall. This word just is very important. It does not clear the wall with sufficient margin. It just clears the top of the wall, means it almost touches the top of the wall. So this is that path. It almost touches the top of the wall. You are asked to find theta 0 so that projectile just touches the top of the wall and clears the wall. So let's follow the procedure. Choose origin where projectile motion starts. Write coordinates of points known in the path. So this point is almost in the path, so we can use coordinates of that point. If motion starts and ends at the same level, of course not. Then check whether equation of path can be used. So what is given? V0, x and y coordinates of a point in the path. And what is asked? Theta 0, and that is what I have told you. If given and asked are amongst these four variables, then we should prefer equation of path. So I am using equation of path. In that we will put V0 as 50 meters per second, theta 0 as alpha, this value is unknown right now. Then x coordinate 25 and y coordinate 12 meters. Now put the values. So y is 12, x is 25, g 9.81, v0 50, x 25. So just put the values in the formula, and now you will get alpha because it is one equation with one unknown. Last step in our procedure of analysis, this I am deliberately writing this step even if it is not required in this problem, because I want to print this procedure on your brain. Okay, but here equation of path is giving us answer. You just want to know alpha. But now most important thing, and all of you do these calculations yourself. When you find angle of projection using equation of path, you get two values of angle of projection, and you must get both the values. Now here that special instruction I am giving you, remember, don't use a alpha key of your calculator to find this angle alpha. One equation with one unknown, so let's use alpha key. Don't do that, because calculator will give you only one answer if you use alpha key and type this equation as it is and get the answer for alpha. You will get only one answer. But there are two values of alpha satisfying this equation. Squared involved here. It is, if you simplify, you will realize that it is a quadratic equation, and then you can use quadratic equation mode. How we proceed with the calculations? Try to understand. Just simple. It is 25 tan alpha. Calculate 9.81 into 25 squared divided by 2 divided by 50 squared. And this is how you get the equation. Then 1 by cos squared alpha is sec squared alpha. Sec squared alpha is 1 plus tan squared alpha. And now you must have realized and use these steps when you find the angle using equation of path. Now again simplify, write it in standard quadratic equation format. Ax squared plus bx plus c equal to 0. What is a? 981 divided by 800. What is b? Minus 25. And what is c? 10581 divided by 800. So ax squared plus bx plus c equal to 0. Here x means a tan alpha. So x squared means tan squared alpha. So here you will get two values of x means two values of tan alpha. Use quadratic equation mode of your calculator. This is how you have found out two values of tan alpha. And then inverse of that, you will have found out two values of alpha. Remember, when you solve a quadratic equation, you get two answers. And when it is a quadratic equation involved, if squared is involved with an unknown in an equation, then write it in proper quadratic equation format, complete the calculations, get both the values and select the correct answer. Sometimes both are correct, sometimes larger correct, sometimes smaller value is correct. It all depends on the situation involved. Now watch here, how come both answers are correct answers? Try to understand. When particle or shot is fired at an angle 28.524 degrees, then it clears the top of the wall, or it almost touches during its motion the top of the wall during its upward motion, and when it is thrown at an angle 87 degrees, very close to 90 degrees, when it is thrown at an angle 87 degrees, it almost clears again, it almost touches the top of the wall and continues to move. So this is how both answers are correct, because after all we are asked to find that angle so that projectile almost touches the top of the wall or just clears the top of the wall. So both are correct answers here. But listen, how you should select correct answer for different situation. Here I have designed the same problem, data same, but designed in this manner. A boy throws a ball from ground with velocity 50 meters per second, and it is caught by a man standing on the roof of the building. Now where this man is standing, coordinates are same, it is 25 meters from the point where ball was thrown, and he is on the roof of a building which is 12 meters high. So at what angle the ball must have been thrown, that is the question. Now of course what you will do, V0 is given, theta 0 to be found out, at what angle ball was thrown, and this man catches the ball in the sense he is in the path of the ball. So use equation of path and you will get the same two answers. But now in this case, not both answers are correct, because he is standing on roof of a building, we can see in the diagram, and ball thrown with smaller angle. Even if hypothetically this man is in that along on the path, but this ball will strike the wall here and it will not reach the man. So here ball is thrown at an angle 87.11 degrees. So here correct answer is 87.11 degrees. So same problem, but situation is little different, and the answer is 87.11. So the problem earlier we solved, both answers were correct, but here only one answer is correct, 87.11. Now watch here. Here it is basketball game going on, and this player here at origin, he wants his ball to enter into the basket. So at what angle he should throw the ball? So of course 87.11. But how will you solve the problem? Since ball enters the basket, basket is in the path of the projectile. So you will use equation of path, you will get both these answers, and the correct answer is 87.11 degrees. Read this problem. A drinking water fountain is designed such that the nozzle is located from an edge of a basin as shown in the figure. Determine maximum and minimum initial speed of the water at the nozzle so that it does not splash over the sides of the basin at P and Q. P and Q are at the same level. Now listen, when water gets ejected from the nozzle at that instant, that is initial speed is U to be found out. So V0 is U here, it is unknown. And what is theta 0? It is angle made by initial velocity with horizontal. So theta 0 is not 50 degrees, but it is angle with horizontal, means 90 minus 50. So in this case theta 0 is 40 degrees. We know that theta 0 is 40 degrees here. And here water should fall in the basin. But we are asked to find maximum and minimum initial speed so that water falls in the basin. So what does that mean? You can easily visualize here. If speed of water is increased here, then at certain speed water strikes point Q, that is the edge of the basin at Q. And if you go on reducing the speed, then at certain speed that water jet will strike the basin at point P. So we should find that value of U so that water strikes point Q, and that is of course maximum value of initial speed, because if you exceed the value of U, then it will not fall in the basin, it will fall beyond point Q. Similarly, with minimum U, water will strike at point B. If value of U is further reduced, then it will not fall in the basin, it will fall somewhere here. Simple problem it is. You find value of U so that point Q in the path, and find value of U so that point P in the path, and this is how you will get the two values of u for maximum and for minimum value of u. If given and asked are amongst these four parameters, then use equation of path. So we are using here equation of path. Origin is this point. Let's focus on this path first. Point Q in the path. So let's follow the procedure. Choose origin. So origin is here. Write coordinates of points in the path. So Q is point in the path. So x coordinate is 40 centimeters. Take care of unit. So 0.4 meters. And origin is this nozzle end. So below origin point Q is. That's why minus 0.12. If motion starts and ends at the same level, of course not. Check whether equation of path can be used. Yes, coordinates of point Q are given. V0 to be found out and theta 0 is given. That is 40 degrees. Theta 0 is angle made by initial velocity with horizontal. So put the values here. V0, theta 0, x and y we are going to put in equation of path. So put these values. So y is minus 0.12. Mug up this formula equation of path expression. It's very important. So put corresponding values. Now listen, here there is only one answer. U squared. Use alpha key and get the answer. Even if it is u squared involved here, there is no other term in which u is. It means it is not ax squared plus bx plus c form. So you will get u squared and then root of u squared, so plus minus. But what is u? It is not velocity, it is magnitude of velocity, which is scalar quantity. So negative answer is a logical answer. So what I mean to say, that is use alpha key, that is type this equation as it is using alpha key and you will get u. And because at this initial speed point Q is in the path, this is the maximum speed we can allow, 2.707 meters per second. So really speaking, it is one step problem. But here one instruction I am giving you, sometimes to complete the calculations, calculator takes its own time. For these calculations, calculator is going to take much time. You may think that calculator is not working properly, but don't think in that manner. Give calculator its own time, and after some time this answer will flash on your calculator. So we have found out maximum u. Now we want to find minimum value of u. So when u is minimum, point just strikes point P. So case 2, and what is that case? Point P in the path. Point P in the path. What are the coordinates of point P? 0.1 and minus 0.12. Now we want to find initial speed when point P is in the path. So just put these values in equation of path and you will get the answer. Same calculations again. So these are the two values of initial speed. Read this problem. A player throws a ball. Here is a player and he throws the ball. A player throws a ball with initial velocity 24 meters per second from point A. Here is point A. Determine maximum height h. Maximum height h. Remember, height is measured from ground, so there is ground level. Determine maximum height h. The ball can strike the wall 30 meters away from the player. So wall is 30 meters away from the player. And the corresponding angle alpha. Listen, this is very important statement. Determine maximum height h. Ball can strike the wall 30 meters away from the player and the corresponding angle alpha. So this maximum height h corresponds to certain angle alpha. So at certain angle alpha, this ball reaches maximum height. Remember this. What is that angle alpha? That is also you are asked to find out. Assume the ball released at height 1.5 meter from the ground. So 1.5 meter above the ground the ball is thrown. Take g 10 meters per second square. So we are going to use value of G 10, not a 9.8, because it's special instruction given in the problem, so we should follow it. Procedure of analysis we are following. Choose origin where motion starts. So point A is origin. Write coordinates of points known or given in the path. Coordinates are distances from origin. So origin, check it where it is, and then you write the coordinate. So what is x coordinate of point B? 30, and y coordinate is YB. It is unknown. But you are asked to find h, height. No problem. We will complete calculation, because in equations of motion or in equation of path, y coordinates are involved and not height. If motion starts and ends at the same level, then check whether range and type. No, not at all. Then check whether equation of path can be used. Yes, because watch here. Initial velocity 24, angle alpha. You want to know maximum y coordinate. So given and asked are among these four variables only. Y coordinate to be found out, theta 0 to be found out. Theta 0 in this case is alpha. So y and theta to be found out, initial angle of velocity, and then x is given, v0 is given. So given and asked are amongst these four parameters, then we use equation of path. So we are going to use equation of path. So v0 24 meters per second, theta 0 is alpha, x coordinate is 30, and y coordinate of point B, y coordinate of point where projectile or that ball strikes the ball, that is YB. So put these values in equation of path. Once you get YB, you can add 1.5 meters to for h. So y is YB, theta 0 is alpha, x is 30, and v0 25. I substituted it. Now check, there are two unknowns here. So how to proceed? So listen, determine maximum height h. You are asked to find maximum height h and corresponding angle alpha. That is what in the problem suggested you to use condition of maxima minima. You want to find maximum. Check here, alpha, if you go on changing values of angle alpha, say alpha is much less, then the ball will strike the wall much below the point shown in the diagram. So at different angle alpha, the point where ball strikes the wall will be different. But we want to know maximum y, and this y coordinate of point where ball strikes the wall is function of alpha. Where if you want y be maximum, then dy by d alpha equal to 0, condition of maxima. So we are going to first differentiate this equation with reference to alpha, and then we'll equate it to 0. Now simplify it. So this is how YB is a function of alpha. Then 1 by cos squared alpha is sec squared alpha. So when YB is maximum, dy by d alpha equal to 0. So differentiate equation with reference to alpha. So 30 sec squared alpha, tan alpha differentiation is sec squared alpha. And here it is sec squared alpha, so 2 sec alpha, and then differentiation of sec alpha, that is sec alpha tan alpha. So this is how we are using condition of maxima minima. Now for YB maximum, dyb by d alpha equal to 0. So put dyb by d alpha equal to 0. Sec squared alpha will get cancelled. Divide this expression by sec squared alpha, and therefore you will get tan alpha, and therefore you will get alpha. This is one of the answers. You are asked to find corresponding angle alpha. Remember, this is the alpha, angle alpha, when dy by d alpha equal to 0. That means this is angle alpha when y is maximum. So put this value of alpha in this equation, in earlier equation, say this equation. So I have substituted alpha is equal to 62.96 degrees in this equation, and I got YB maximum. But before you write final answer, don't forget you are asked h. So add 1.5 and then you write the answer. So h max is equal to 23.23 meters. So this is how we have answered the problem. In this lecture, we have solved all problems, check, using equation of path. the given information and what you are asked in the problem are amongst these four variables v0, theta 0, x and y. In that case, we use equation of path. Remember the procedure of analysis. Don't solve any problem using trial error method. Just follow the procedure. Visualize the motion, and to visualize the motion, draw line diagram of the motion and follow the procedure. Choose origin, right coordinates. If motion starts and ends at the same level, we have not yet solved that type of problem yet, but we'll solve it in another lecture. Check equation of path can be used, and if equation of path is not sufficient, then use equations of motion. This is the right procedure.